Let's talk for just a minute about the growth and decay formulas. They're exponential growth and decay. So we look at the basic exponential form, y equals a times b to the x power. For growth formulas, this one is where b is greater than 1. And for decay, b would be less than 1. So sometimes you'll see it written like this with a equals p times 1 plus r to the t power, where A would be your final amount of whatever you're talking about, like bacteria, population size, the value of your house, for instance. P is the principal amount. So what did you start with? How much did you spend on the house? What was the population size before it grew? R is rate and T is time, and the 1 is always part of your formula. Because B is greater than 1, it would make sense to add to 1, so it'd be more than 100% of what you started with, for example, because the 1 represents 100%. So for decay, we can use the same idea here, and the same formula applies to decay. It's just 1 minus R. So it makes sense that if the 1 is 100% and you subtract the rate, then B is less than 1. So these two formulas go hand in hand. It's just that sometimes you might see it written with just a number there that's already been put together, and sometimes you could see it written where it's 1 minus the rate. If these letters are not A and P, they still represent the same thing. Like if you still see Y equals right there, Y would still be your final amount if you're talking about growth or decay. So I've labeled all the variables down here, but notice these are identical. So in your notes, you could put just one set of these definitions in your notes to go with these two formulas. So let's look at some examples real quick. So if you're given the formula set up and you're asked what is the rate of exponential growth or decay, you can pick it out by knowing B is greater than 1 for growth and B is less than 1 for decay. So for number 1, I'm only looking at the value in the parentheses. The 3 is not part of this question. The rate of growth or decay is what is to a power. So 1 plus 0.12 is what was there to give me the 1.12. So the rate here would just be 12%. We change percents into decimals. So 0.12 represents 12% in the same way that the 1 represents 100%. So if we look at number 2, we have 1.3. So the 0.3 is how much bigger than 1 it was. So this one is growing, so it's a growth formula because it's larger than 1 by 30%, because 0.3 equals 30%. So we'll put all that right there. So this one was a growth of 12%. I need to write that word down. Let's look at number 3. We have a cost varies as time, like a function of cost as a function of time is what I'm trying to say. Starting with 5,000, but right here would be the answer to our question. So all that other stuff really doesn't matter if you're just asked what's the rate of growth or decay. So 0.75 is 25% less than 1. 0.75 is equal to 75%. But that's less than 1 by 25%. So 1 minus 0.25 is where you could have come up with 0.75. So this one was a decay at a rate of 25%. Because it's less than 1, it's decay, or depreciated, or declined, or it went down in value somehow by 25%. So for number 4, again, this other stuff really doesn't matter. We're just looking at 0.95. How much less than 1, because that's less than 1, is 0.95. So 0.95 is 0.05 less than 1. So this one was a decay at a rate of 5%. For number 5, A equals 0.0812 times 1.03 to the t power. So this one is larger than 1, so it's growing by a rate of how much larger than 1? It was 0.03 larger, which is a 3% growth rate. And for the last one, we look at the 0.90. That's less than 1, so this one was decay, or declined, or depreciated. Usually they're D words that we use with these, but it's a decay of 10%. because 0.9 is 1 minus 0.1. That's where that came from. So 1 minus 0.10 is a decay of 10%. So they could just ask this question, given the formula, what's the rate of growth or decay? So that's why it's important to look at it kind of naked, like it doesn't have a word problem with it, just looking at the formula. Now let's look at two problems that have more of a story behind them. So this one says, Will bought a computer for $950. It's expected to depreciate at a steady rate of 20% per year. What will the value of his computer be in 5 years? So we would set it up as a decay formula because it said it depreciated. Depreciated means it went down in value, so that goes with our decay formula. So we would say A equals P 1 minus R to the T power. So A is what we're looking for. What's it going to be worth? P is the principal amount that he spent on the computer. 1 is always part of our formula because we look at 1, is it bigger than 1 or is it less than 1? So it's going to be less than 1 because we're depreciating. It's going down in value. It'll be worth less than 100% of what he paid for it. So 1 minus the rate, which was 20%. So 1 minus 0.20, and time we put in directly as 5. And then I calculated that in my calculator, and I got that his computer, not his calculator, is worth $311.30, which sounds about right for the sake of computers. That's probably more than he would get for it if he tried to sell it on Craigslist or something, but that would be his final amount that it's worth. Let's look at an example for number 2. Mr. and Mrs. Watson bought a condo at the beach for $75,000, assuming that its value will appreciate because beach property tends to appreciate because it's valuable because there's only a certain amount of it. So if it appreciates at a rate of 7% per year, how much will the condo be worth in 10 years? Maybe they need to sell it, have some retirement money or something. We don't know. But we need to use the appreciation formula, which would go with growth, because appreciate means that it gained value. So it's going to be more than 100%. So more than 1 is what we need. And so what will it be worth? We're looking for that. They started with a $75,000 investment. It went up 7%, so we put 0.07, change your percent to a decimal, and put in time as 10 years. So in my calculating, I came up with that it will be worth a whopping $147,536.35. So as you can tell, a condo at the beach would be worth an investment because it normally appreciates in value.